right, let's go ahead and get started. Welcome everyone to the Building Microservices with the Converged Oracle Database Developer Lab. My name is Tara Van Cleve, and I'm a Marketing Event Manager for the Developer Initiative here at Oracle. Today, we're excited to show you how to modernize and simplify your data-driven applications with microservices architecture using Database Cloud and Helidon on Oracle Cloud Infrastructure. We'll be recording today's session, so if you'd like to follow along with the lab walkthrough and then complete the lab later on at your own pace, we'll be sending the link to the recording in the next couple of days to your email, and it will also be available on the Modern App Dev series page and Oracle Developer YouTube channel. You'll also have the opportunity to participate in a short quiz on the material covered in today's lab. Upon completing the quiz, you'll receive a Developer Masterclass badge that you can share to your social media, recognizing your commitment and earned expertise. If you have any questions during the lab, please ask them in the Q&A area, and we'll have several solutions experts available to answer them throughout the session. Today's lab will be presented by Paul Parkinson, Developer Evangelist, and Robert Exley, Consulting Member of Technical Staff. So without further ado, I will turn it over to Paul.
Right, thank you so much, Tara, and thank you everyone for coming out. We're definitely excited to give this workshop. We've been, it's a team of us that work on this workshop for a few years now, and so Rena and Paula from the team are also on here to help with any questions. So definitely feel free to give any feedback or questions. What you'll be building today or watching and building later is a grab dish fictional food delivery service application built on a microservices architecture. And so, within you will not, be able to get through all of these labs in 2 hours, but you will be able to get through quite a bit and be able to, within a short period of time, build this entire architecture. And certainly you'll be able to get a lot of this done in 2 hours. But for example, after the first lab, this whole infrastructure layer here will be set up for you. So after running a few scripts that Richard's going to go through, you'll have provisioned all of the OCI infrastructure for your repository, for your images, for your microservices, object storage, 2 databases, with the messaging broker event mesh communication between the 2 of them, and you'll be ready to start deploying microservices and using them. And like I say, we'll build up from there. So this workshop, as Tara mentioned, you can come back to this later on, and all of the source code is in this public repo here. So if you ever want to just look at parts of the source code or refer to what's going on, behind the scenes, everything here is in this source repo. Everything you need is there. And then this repo in turn has a link actually back to the documentation for the lab that we'll be going through. So just to break down the agenda a little bit more, I'll just spend a couple of minutes here while you're getting your account set up. The first thing we're going to do is that lab 1 that I mentioned. So Richard will spend 5 or 10 minutes just showing how to get into Cloud Shell and run the scripts and everything to provision the infrastructure I just mentioned. While that setup script is running, I'm going to do a short 15-minute presentation to go over all the concepts of what you're going to be building, so you understand exactly what we're doing here. And so the setup will take maybe 10-15 minutes, and while you're waiting for that to happen, you can listen to me present the concepts that will be in the workshop. And so I mentioned here the core of this, of course, is that we're using the Converged Oracle database and AQ. And just so I'll be just describing a lot about AQ through the presentation and the lab, but just up front, I'll let you know that AQ is the advanced queuing messaging service that's been in the database for decades. So it's actually part of the database. It's not separate. And we'll be using the classic queues in this workshop. We'll be adapting and providing the transactional sharded queues in the future, but the usage will be the same. So I just wanted to let you know that we're using classic AQs in this workshop. From there, I will go through the lab 2, which is has the real core of this workshop. All of the concepts I described in the presentation are shown in the second lab. So this is really a lot of functionality in this second lab. And so I'll walk through the documentation, explaining all the concepts and how they're demonstrated in the application. I'll then hand it back to Richard, who will go over lab 3, which is the polyglot and different frameworks lab. And so what this is showing is, the main example here is an order inventory kind of flow. And so we have an order microservice and an inventory service. And in lab 3, we swap out the inventory service implementation in various different languages and frameworks. So, for example, Python, Node, .NET, Go, covered most of the big, popular languages. And then also in Spring Boot. So Spring Boot is probably the most popular microservices platform that is still, but there are quite a number of different frameworks. And we use for the core lab 2, we use the Helidon microservices framework, and specifically the microprofile Helidon framework. And one of the reasons we do that is because microprofile is a standard that is kind of catered to Java EE developers. So if you're migrating off of a monolith application server, whatever the case may be, you're familiar with Java EE. When you move to microprofile and Helidon microprofile, it's going to be very familiar to you. So that's what we use in lab 2. Then we'll move on to lab 4, and Richard will show the scaling both at the app microservice layer in Kubernetes and at the database layer. And I'll run performance tests to show that the change in metrics and performance as a result of that. I'll take back control and show lab 5, observability. So of course, observability is very important with microservices. And so I will show our unified observability strategy in Oracle, where we show that the so-called 3 pillars of metrics, logging, and tracing for both the app, Kubernetes microservices layer, and the database, Oracle database tier, and we show them all within Grafana. So I'll go through that. We're going to be handing things back and forth. I'll then hand this back to Richard, and he'll go over the Apex no-code, low-code microservices offering in the database, and show an ops dashboard there. And then he will hand it back to me, and I will expand upon some of the concepts I mentioned in the presentation in lab 2, but show you some very concrete failure recovery scenarios as far as transactionality and message delivery, comparing and contrasting Oracle TEQ, again, that's AQ, to AQ TEQ, essentially the same. TEQ is the latest version that has sharding support, et cetera. So I'll compare the Oracle Converged database and messaging offering to Kafka with, say, MongoDB and PostgreSQL, and show when something fails here, the difference in between the 2 solutions. And then finally, Richard will wrap up with just the basic infrastructure teardown, if you want to tear this down. And so with that, I will go ahead and hand this over to Richard to start with lab 1.
Okay, thank you, Paul. Let me just jump in here now and show you how to begin the setup of the application. I'm assuming here that the folks who want to run the lab today have got their free trial accounts. And the first thing you want to do is to log into your free trial account. And on the screen here, you can see my free trial account, and I'm just logged in. And so what we're going to do now is follow the steps in the workshop documentation. A link was shared to the documentation in the chat. And what I recommend is that you have your tenancy login in one tab, and then you have in the second tab, like I have, the documentation in the second tab, or if you've got the real estate on your screen, two screens side by side. And once you get organized like that, then you're going to find it much easier to jump backwards and forwards as you switch from documentation to the executing the workshop in the lab. So following right along here, lab one is the setup. The first thing we do, as I said, is we log into your OCI account. Second thing you want to do then is make sure that you're selecting the home region in your tenancy. So to do that, there's a drop down here, like it shows here right now that I'm in Phoenix. And in my case, I only have Phoenix as an option, so that's not a problem. But if you have more than one option here, make sure you select the home region. Third thing we do here is we take a look around and we see, I think I've got the wrong, just realized I think I might have the wrong documentation here somehow. I apologize. Let me just go back and make sure I'm on the right page here. I think I selected the wrong thing right at the beginning. Here you go. This is where I should be. All right, so setup, and task 3 is check your tenancy limits. So if this is a completely new tenancy that you're working with here, then you should be absolutely fine. If you've actually run some other workshops inside your tenancy, then you may find that you've already used up some of these resources. In order for us to be able to run this workshop, we need to have at least 3 compute CPUs available. We need quota for 1 container engine, an OKE cluster. We need at least 2 terabytes of autonomous transaction processing database available. And we also need at least 3 load balancing routers available. So the way you can check this is you can go to your tenancy, and you can go to governance and administration, and then you can look at limits, quota, and usage here, and then you can check out the specific things that you're interested in here. Like, for example, I'm looking in AD1, and I can see if I scan down here to the compute, then you can see that I have 6 available here, and I only need 3. So this can be a little take a little time, but if you have used your tenancy before, then it's a good idea to check that you have the quota that you need, so that you don't run into problems further on. The workshop itself actually does check this too. The scripts check this too, but let's try not to run into any problems. It's better if you run clean here and not try and do things too quickly, because you can quickly run into problems. So the next thing we want to do now is then launch the Cloud Shell, and that is done by clicking this button right up here. And when you click on that button here, you basically get your own shell environment connected directly to the console here, where you can run scripts. This is very handy. It's already configured with the OCI CLI, kubectl, SQL+. All the tools you need to do this workshop are already pre-installed inside the Cloud Shell. So it's a very convenient place to quickly do some prototyping or checking out the different features inside the Oracle Cloud. Okay, so I started the Cloud Shell. I now want to create a folder where I'm going to run the workshop, and I'm going to call my folder dev, as this is a dev workshop, and then I want to cd to the dev folder. Okay, so that's the next thing we do. And then we pull down the workshop code from our GitHub repository. This is the place that Paul was talking about, where all our code is available for you to check out. There's even the code that we use to run the setup of the workshop as well, which can actually be very useful. We provision the ATP databases and the Kubernetes cluster using Terraform, and you can see how that's done if you check out the code that we have here. Okay, so I'm going to copy this, and I'm going to paste into my Cloud Shell, and it's going to quickly pull down all our code here. So now if we ls here, we see that we've got a new folder in here with all our code in there. The next thing we do is we run a quick command, which is going to register all of this inside our .bash RC shell script. And what that means is if we log out and we log back in again, we get back to the same place. So we don't have to remember how to get back to the same spot. And it also sources all the right environment variables. And now what we can do is we can run the setup script. So we copy this out of the instructions here, and we paste into here. And now there's a Q&A that's going to happen here. It's going to ask us a few questions, and then it's going to run for about 50 minutes to run the setup. So the first question it's going to ask is for your users OCI ID. So one way you can get this is to go to the profile menu, which is this button right on the top right-hand corner here. If you've only very recently provisioned your tenancy, you may not have some of these options here. If you have the options here, then you can click on the user settings, and you get directly to the page where you can get your user OCID. The other way you can get to this is you can go to the hamburger menu on the top left-hand corner. You can go to identity and security, and you can go to users. And there you want to select the non-federated user here. And then you can copy the OCID out of here, like this copy, and then you can paste it into your Cloud Shell. It takes that information. With that OCID, it can now go and discover a lot more things about your tenancy. It starts running a lot of different things in the background. One of the things it's now done is just to remind you that this setup is going to provision an OKE cluster. Typically, with a free trial account, you only have a limit of one OKE cluster. So make sure that there's no other OKE clusters in your tenancy before you hit return here. I know I don't have any because I cleaned up yesterday. It also does a check to make sure that you have enough space for an ATP database. And now it's going through the process of logging you into to Docker by creating an authentication token and getting the setup started. And then two final questions. One is, which password do you want to use for the databases? And the second question, which is, which passwords you want to use for the UI? It's important to read the instructions here carefully. The password needs to be at least 12 characters long, at least one uppercase letter, one lowercase letter, and at least one number. And you can't use the double quote or the word admin in this password. So I'm going to enter my secret password here, and you can choose whichever password you'd like when you do this setup. And I'm also going to enter the UI password, which is much simpler. And now the setup is going to go through the process of setting up the resources we need for the workshop. And this typically runs around 15 minutes. So I'm now going to hand back to Paul, where he can give you a little more of the background and architecture of the workshop while we're waiting for the setup to run.
Yeah, and that's awesome. I mean, what's couple IDs and a couple passwords, and you have Kubernetes cluster, like all that stuff I mentioned. So that while we're waiting for that infrastructure to be provisioned, if you're exercising the lab as we're going through here, I'm going to talk about some of the concepts, as I mentioned, that you'll see in the workshop. So, start at the beginning. What are microservices? So, a lot has been put on top of microservices as far as, what they should be, what they shouldn't be, things like that. But the original definitions are quite basic. And I think it's first defined in 2014 by Fowler, but then at Netflix, where they really, went into use by Adrian Cockcroft. And he, just gave this quote as far as it being a loosely coupled service-oriented architecture with bounded context. Okay, and so if we break it down, loosely coupled. So this is how everyone was supposed to design their software anyway, right? But this is, really breaking it apart into these boundaries. And so, as it says, if you have to be updated at the same time, it's not loosely coupled. And then the other aspect being that it's bounded. If you know too much about their surrounding services, you don't have a bounded context. And so these are two key points in the design, and these are the two key points that give the advantages that people are, adopting microservices for. And here are just some of them. And if you only had to name, one, the deployment model is such a massive difference between the monolith and microservice architecture. Okay, and so there's a list of different things here, but a lot of them come down to that deployment model, the fact that you can decouple things to optimize and make maintenance easier, have superior fault isolation. So, there's a bug in part of your system or something goes wrong with part of your system, you don't have to bring down the whole monolith to patch it. You can isolate it to one area, bring in another implementation. This allows, this dynamic allows for blue-green deployment, where you can try out new implementations, mirror traffic to different implementations without without the need to patch a full monolith and things like that and bring systems down. So, the advantages have definitely been proven out as far as the microservice architecture. And then there are others as far as the ability to scale better, because you can do it at these finer grain levels, you can optimize and things like that. So these are a number of the advantages. And then, as far as then exactly what is a microservice, we see there's really a spectrum, and we've seen this over and over again with customers as far as, there's the Netflix with 1 million microservices. And then there's the, I'm just coming off of an application server and I want to have a cell phone, a mobile front end, So you can go from 2 services to 1 million services, and they're all valid for fitting particular use cases. And then, of course, you have this trade-off across the spectrum as far as data integrity. The more services, it becomes more difficult. And we're discussing a number of different areas here, but data, pretty much everyone agrees data is probably the hardest issue with microservices. That's what we've really focused on, making that powerful and simpler in that area. But again, these are all suited to different needs. And that's what's great about the Oracle database, just the actual design of its multi-tenancy and the pluggable databases. If you're not familiar with that architecture, Oracle, for a very long time now, actually has had the concept of pluggable databases, where there's a core container database, but you have individual pluggable databases that sit on it. So you get all the advantages of having this common core as far as backing up, synchronization, and things like that. But you have this isolation at this portable database layer. And so that predates the microservices kind of popularity, but it's a perfect match. And so, because again, isolation, going back to the original definition, isolation is a very key point of microservices. And so you want to be able to isolate at different levels. At this, the purest definition you'll hear in microservices is the model of a service per database. And with Oracle, you can do that with the pluggable database. You can also do it at the schema level because it's isolated. But again, you can also do it at the pluggable database. So you get all of the advantages of, stated in these kind of stricter laws that some people state as far as, one database per service. but you get all this data integrity and aspects that I'm going to go into more detail now when you use the Converged database. And so there are different ways to do a microservice architecture, and one is the kind of, you have a number of different producers and consumers, and then they are wired together with, say, Apache Kafka. And so you have this many different technologies. The very serious issue of copy contagion, multiple data copies. You don't have quite the control over the data integrity, which again is one of the biggest issues that people will find when they go from monolith to microservice, or even from greenfields. And then your skill set is scattered. You have to have people with knowledge in a number of different technologies. And so using the Converged database, we address that by having this centralized database. Administration is in one spot. That's a big one. Administering all these disparate systems is both complicated to coordinate, but again, to the point of data integrity, you're administering, this one's going down at this certain point, this one's being updated at this certain point. In a Converged database, you have, you take that issue away. And then, what we show in the workshop, we show a number of these concepts in the workshop, is the different types of data, JSON, traditional, SQL relational, spatial, XML, all the graph functionality of all these specialized databases. All of them are supported in the Oracle database, and in the most robust way. You're getting all these other benefits of the Oracle database, but you're getting them with all these different data types as well, and data models. And so, it's easy to reuse APIs, the support for all the APIs you may have in these other products. And we've adapted them, Mongo, Kafka, all that type of thing. You can still use your knowledge of that with the Oracle database. And so, as I mentioned, any data type, and we're going to show a bunch of them in the workshop, any type of workload. Of course, Oracle has supported these customized workload services for a while now, and now we have sharding, and then it's the most productive as far as AI/ML and in the database, developers, architects, database analysts, etc. And so on this slide, to this point, I'm going to open up a poll to just kind of gauge where you're coming from, so we know what the audience is. And so this is just asking you, if you wouldn't mind, to answer this poll to describe what role best fits you. That would be great. While you're doing that, I'll continue on. So mentioning this, the fact that Oracle brings all of this functionality, we want to also make it clear that we're not talking about some vendor lock-in, and it's just the opposite. Everything we're talking about here is an open standard, or it's a standard, as I say, that's even adaptable to other products, not just open standards. So for example, Kafka on the right is a product, JMS is a standard, and then all the Cloud Native Compute Foundation standards on the left, service meshes and things like that. It's all open standards that we're talking about here. So it's not a lock-in. It's just additional features and abilities, as they say, that are provided by the Converged database, and that includes, as you'll see in the Polygon Lab, support for multiple languages. Whatever language you want to bring. And so this is kind of just a stacked representation of what I just mentioned. This is how things fall in line. Public, private cloud, we have an on-prem version of this workshop now, all the various versions of the underlying infrastructure, and then the cloud native environment, et cetera, that I just mentioned. And this is kind of how it looks in stack format. So now there's a lot of content here. And I'm going to repeat this a number of times, that this is a very full 2 hours that you're in. So I don't want anyone to feel frustrated. And as Tara said, this is going to be recorded and you can watch it later, so you can do the workshop later, or whatever combination, because I know we're covering a lot of material here. But hopefully you get your money's worth. So a lot of these patterns, these key microservice patterns, are in the workshop. All those with an asterisk next to them are actually in the workshop. Actually, infrastructure management is as well. I should have put an asterisk next to that. That's the dynamic management that Richard's shown you. Data refactoring, that's a big request for migrating from monoliths to microservices, is coming up with these bounded contexts and isolation that you need, finding the usage in existing systems. And so we're doing a lot of work in that area, and there are going to be future features really soon in that area. So support for service mesh, and along with that, event mesh. So just very quickly, service mesh, if you're familiar with the Kubernetes and the fact that Kubernetes has become very present in so many architectures, particularly microservice architectures, that's becoming the case with service and event mesh, becoming ubiquitous with this type of architecture. And so what a service mesh provides is basically an interceptor framework for your microservices, so that you can push all the cross-cutting concerns out to it. So a service mesh will sit in front of your microservice container and intercept traffic. And by doing so, it can take care of security, mutual TLS, tracing, traffic control. So it's great for used in cooperation with Kubernetes, of course, for all these blue-green deployments, these mirroring, where you can send mirrored traffic to your QA and production systems and things like that. So that's what a service mesh is, and you can see that that's become very popular, because then microservices can just have the business logic in them. And so the service mesh is for sync communication, generally REST. An event mesh is more or less the same idea as a service mesh, but for async communication. And we see a lot more async communication, messaging, eventing in microservice architectures, because of the fact that it's more fault tolerant. A microservice can be down when it's sent a request, and it comes up and just dequeues the request, rather than having this retry logic or whatever the fault tolerance is. And just the ability to scale and things like that have made async communication more and more popular, particularly as you're moving closer to the back end, closer to the data. Event sourcing is a pattern where, in particular, because we're using so much more eventing and async communication with microservices, you basically have two operations, right? They are the manipulation of data and sending a message or communicating that change of data to another microservice, right? In the basis, that's what it comes down to. And so you have these two bits of information. And with event sourcing, in order for microservices to decouple themselves, this has become a very popular pattern. This is an old pattern, but has become popular with microservices, because a microservice will simply listen to events that it's interested in. So in the workshop, again, we use the order service and an inventory service. And the order service does not directly call the inventory service with a REST call or something like that. It changes order information, and a message about that order change is received by the inventory service. And so you have this nice decoupling, and the inventory service is then sourcing its information from the event, thus event sourcing, the name. And so again, that's become a popular pattern, and that works in cooperation with command query responsibility segregation. So again, a lot of the advantages we're getting from microservices are the fact that you can decouple them, that you've decoupled them, and as a result, you can optimize. And so generally in traditional systems, the command and query API or interface you're using is the same. you're using SQL to do inserts and updates, and you're using SQL to use select, or whatever the interface may be, SQL, being an example. By using CQRS, you can use one API that's optimized for commands and one that's optimized for queries. And so the example I just gave and that's in the workshop is that you're inserting an order into the database. And so your command, as we'll see, is an insert of a JSON document. But the query is the result of an event. So the inventory service receiving that is not because it read directly from the database, it's because it received an event. And so you've optimized the reads to be messages. And so that's an example of CQRS. And we show that in the other direction as well, as far as inventory back to order in the workshop. The transactional outbox is related to the event sourcing pattern in that, as I mentioned, you have two operations. And as soon as you hear you have two operations, the question of atomicity between the two comes into play. What if you manipulated that data and but the message wasn't sent, or the message was sent and not received, and things like that. Duplicate message delivery and things like that. So I'm going to go into this a bit more in the next slide. So I'm just touching on it here. But that also is related to idempotent consumers. The fact that the receiving microservice needs to be able to handle multiple duplicate requests, or needs to have something in place to make sure it doesn't receive multiple duplicate requests. And these are the challenges in the microservices environment that have to be, it's not all advantages. There are things you need to account for to take it, to have these advantages. Then comes on to the next aspect of data integrity, which is the fact that you have multiple microservices changing data, and they need to belong to the same, whatever you want to call it, business activity, transaction, and generally, a long-running transaction, say. And how do you do this but keep data integrity? One microservice changed something, the other attempts it but fails. The first one needs to roll back. How do you do this in a microservice environment when the older locking protocols aren't as appropriate? Because if you're using, two-phase commit next day or something like that, those are locking protocols. And so by nature, you're trying to decouple. And so if you have these locking protocols, you can run into trouble, not just with throughput in performance, but actual issues as far as locks being held open that will, disrupt your app behavior. And then finally, observability, and I'll go into that more in the workshop. So quickly, the event mesh, I was just talking about sourcing events. I described most of this, but what is extremely unique about the Oracle database, and this is such a powerful feature, I have to stress this, and I'll stress it again when we walk through the workshop, is the ability to conduct changes in the database and send messages within the same local transaction. So if you'll recall, I said earlier, the advanced queuing or transactional event queues, same idea, same thing. That messaging system is in the database, and it's been in the database for decades, long before Kafka was around, actually. So it's very hardened, and because it's in the database, you get this very unique feature, which is what I just mentioned. You can manipulate data and send a message in the same transaction so that either both happen or neither of them happen. And so this allows you, your microservice developer, to code his microservice to not need to account for the fact that it may get duplicate messages or lost messages, for that matter. And that's, has massive effects. And you'll see that in the very last lab of this workshop. And so that's what I'm showing here is just the advantages of that, the fact that AQ provides that. And finally, again, I'll get into this more in the workshop in the lab devoted to observability. But observability becomes very important with microservices. You've now separated your services across a network. And so you need to trace them. It's not just one monolith log. It's, multiple services. And so the three pillars, as they're called, of observability are tracing, metrics, and logs. And so Grafana has done some nice work. Generally, in the past, this has meant three different consoles. You're looking at a console for tracing, one for metrics, one for logs. And Grafana has been doing a lot of great work in providing a single pane of glass view in Grafana, where you can view all three of these and have correlations. So you can have a log, you can be looking at your metrics, drill into that, the corresponding logs. In the log, you look at a log message that has a trace ID, you can click on the trace ID and it will take you to the trace, the Jaeger trace or whatever it may be. So very powerful to have that in one console. And so what we've done is take that, all three of those aspects in the same console and applied it not only to the Kubernetes microservices tier and not only to the database tier, but at the same time within the same console. So this is very powerful for observability. And this is something that's been missing, is this whole picture. And so I'll show you more of that in the workshop. But let's jump into the workshop now that I've explained this. Hopefully, if you are going along with this, your setup has been completed by now. So let me end the poll here. Okay, I'll share the results with you guys, but I figured I'd share the picture as well. So this is great. First of all, thanks everyone. Over 80% of you replied. And this is a great mix. This is pretty representative of the mix we generally see. And this is exactly, what you would expect. This is the microservices blend. The data scientist aspect reminds me that of two things. One, we are constantly adding things to this workshop. And one of them within the next couple of days is an AI/ML example of pairing for this GrabDish app. You order something, it'll suggest a pairing based on that. So, that's the first thing I wanted to mention. The second thing is just that if you have any feedback whatsoever, we crave any feedback you have, questions or advice, things you'd like to see. And, in the past, people have said, I want to see some certain aspect or some certain feature, and we've added it in the workshop. So, in any of these avenues we've mentioned, all the workshop page, you can comment in GitHub, contact us in any of these fashions, from any of these angles, any of these roles, and we're happy to help and appreciate the feedback. So I'll start to go into a walkthrough of Lab 2. And again, we're going to try and get through as many of these workshops, walking through them with you now. But there's no way you're going to get through all of these. So please don't feel frustrated if you're still in the setup or anything like that. Or if, I'm talking about Lab 6 and you're on Lab 1 or 2 or something like that, this is something you can come back to. So to that point, starting with Lab 2, there's actually also a video here, a 5-minute video of a walkthrough of this Lab 2. And so what I'm talking about here is without sound, it's illustrated in this video. And so there's a lot in Lab 2, as I mentioned earlier. The first thing is, I'll just go through these very quickly and then go into more. Deploying the actual microservices. So that's just one script command. And then we'll access the front end. We'll look at this task 3. So this is, this lab has the most content, and then task 3 has the most content within that lab, probably. This is where we're going to show the saga, the event sourcing, CQRS, the event mesh, and things like that, through a basic example of placing an order and then the inventory being checked. Then we'll show spatial functionality. So we'll, again, another data type, spatial. And then we'll show some CNCF basics, so Cloud Native Compute Foundation standards, such as metrics, health, and things like that. And then 7, 8, 9 are really just more study concepts. So you understand what's going on in order to get this connectivity to the database, right? First things first, connecting the microservice to the database. And so this is all laid out step by step. And how the credentials are brought into the microservice, how nice and portable that is. I'll explain more. And then, once you have this going, building off of this. So that's the great thing about the workshop is you have it installed, you can come back and start tweaking it for your own use case. And it's very easy, short little crib sheet here on the development process. So task one, after your setup is complete, you're in the Cloud Shell and you simply want to copy this command to CD into the Grab Dish Home and deploy. And this is just running through and creating your Kubernetes deployments and the Kubernetes services in the case of those that are fronted by REST and deploying them. So pretty straightforward. And for the basic app, we have front end, order, supplier, and inventory. When you're once you've done that, you just go ahead and issue this command in the Cloud Shell and wait until they're in the running state. Then it just takes about a minute. And then go ahead and find out what the Ingress load balancer front end IP address is, so you know how to access it. And so you'll just issue this command and find the IP for the Ingress controller. And you then go ahead and pop that into the browser to access it. And for security, we have this is secured by HTTPS. But we're just using a self-signed certificate. And so you'll have to do that thing in your browser where you say, okay, I accept this, this unknown authority because it's a self-signed certificate. And that's different in different browsers, but you just need to accept that. And then you'll be prompted with a login. And the username is GrabDish, and the password is the password you entered during the setup that Richard mentioned, okay? And that'll bring you to your front end microservice. So this is your first microservice that you're seeing. It's just this front end and the different tab selections on the left there. So task 3, you'll go ahead and select the transactional menu item there and then select the get inventory. And you can, just leave these default. You can change this to pizza or burger or whatever, but you just leave the defaults and then do get inventory. And if this is your first run, it should return that the inventory count is 0. And if it's not, you can just hit remove inventory to get it to 0. Okay, and then we're going to try and place an order. So just click place order. And we show the intermediate state of pending just to show you the discrete stages that this is going through. So it's in pending. Then you click show order, again for this order 66, and you'll see the expected failed inventory does not exist. So let's discuss what happened in this basic scenario. The front end sent a REST request to the order service, okay? The order service inserted the order in the database in using the JSON API, JSON format. And in that same transaction sent a message of order placed. Okay, so this is the transactional event mesh aspect. So that message was then received or dequeued by the inventory service. The inventory service does 3 actions. It within the same transaction. It dequeues that order placed message. It checks the inventory. In this case, the inventory was 0, so it doesn't exist, and so the order will fail. It enqueues that failed inventory message on the inventory queue. So those 3 are done in the same transaction. That message is then dequeued in turn by the order service, and it conducts 2 actions. It dequeues that message and then updates the order status to failed in this case because the inventory didn't exist, and then reports it back to the front end. Okay, so what we saw there again is this eventing and the saga pattern where just to talk a little bit more about that. We don't have locking. We're not using locking because of the disadvantages it has. and so we need this instead a pattern called the Saga pattern. And so what the Saga pattern has, instead of locking and implicit behind the scenes commit and rollback, a Saga is only local transactions, no distributed locking. And so it needs to define compensating activities for each of its activities. This is the extra work of Sagas to get this decoupling feature or advantage. And so what we have defined here is the compensating action is put the inventory back, whatever the inventory action is for something that failed, put that back. And then the compensating activity for the order service is to set the status of the order to failed. Okay. And it's a whole another presentation, but we have features in the database to automatically do this compensation. And so this is a huge area where the Oracle database has an advantage. And we'll be adding that to the workshop, that feature as far as auto compensating. But for now, let's just leave it at that. And so we'll go into the next scenario where we have success. We'll add inventory. You see this, the order is now 1. Then we'll place the order, it's in pending, click show order, and it will show a successful order. And it will also show the actual inventory location and suggestive sale. And so what a successful order is showing, in addition to the failed order, is that concept of CQRS, where we did the order insert, but with the classic JSON insert. But the query for the order detail that we do with show order is completely constructed out of events. The order service did not contact the inventory service, and it did not contact the database directly to get the information about this order. It received messages from the inventory service, and because of that, it can show this. So it's a very simple example of a CQRS pattern. And so this is a little write-up that says a bunch of what I said already, if you want to read it later. And this is the extremely powerful, this one line of code is, the most powerful thing. This is where it is showing a queue. And again, the advanced queuing in the database is supported by all these different languages that we have, and you'll see in the next lab. And in the core lab, we're using Java with Helidon, as I mentioned. So we're using JMS. And the AQ JMS API has this call where you can actually get the JDBC connection of the underlying JMS session. And when you're working on that JDBC connection, you're doing it in the same transaction as your JMS session. And so this one line is how you get all of that power. And we've worked with a number of other frameworks where you don't even have this one line. You're just actually getting it through annotations and things like that. So super easy, super powerful. This one line here is really something. And like I say, it's been around for decades. So now we'll move on to viewing spatial data. So this is basically you're placing an order, but doing it through this spatial button here. So if you click the spatial button and click a type of food and then select that type of food, click ready to order, and then hit deliver here. You can accept all these defaults. This will bring you into a map showing you from the delivery location to from the inventory location to the delivery location. And so this is just showing off the spatial data type. Next, we'll move on to, I'm going very quickly because I'd like to get through as many labs as possible, and we only have an hour left. The next thing we'll show here is metrics. So if you go onto this third tab of Open API Metrics Health and click on metrics, you will see just a dump of Prometheus metrics for the order service. Okay, and this is just showing the endpoint and that concept. And you can look in the code to see how this is done just by slapping this annotation on there. Okay, the observability lab, I'll get into showing this, really visualizing it and showing it nicely. The next CNCF technology we show is health probes. And so this is a technology that works with Kubernetes health probes. So a Kubernetes health probe is something you define in your Kubernetes deployment YAML. And again, all this is in the repo and all of it's explained here in more detail when you have the chance. But in short, you define in your deployment YAML for your Kubernetes microservice, your order service in this case, you say health probe and then probe for readiness and liveness. And your microservice will have an endpoint that advertises if it's live and if it's ready, ready to take requests. And if it says that it's not, Kubernetes will automatically restart that pod. So it has this nice, resilience as far as handling failures in that way. And so that's what this step shows. We intentionally set the health to false, and we witness the fact that the Kubernetes probe comes around and restarts the probe for us, or restarts the microservice for us. Okay. And we do that by checking the container start time. And so, again, as I mentioned, these are just study tasks. This one shows how we're passing in credentials to the microservice. Okay, and this is in your Kubernetes deployment file. And then how the credentials are used by the Helidon microservice. So I'll just describe this very quickly. In Kubernetes, if you're not familiar, there is, there are a number of different resource types. And three of the big ones are your deployment, your service, and secrets. And so secrets are what contain any kind of credential and connection information that you need. And you can store this information in vaults, in other locations, but Kubernetes secrets is one option. And just on a side note, one thing we are also adding to this workshop in the next couple of weeks is the use of the DB operator that is coming out. And that helps to automate some of the things in the script here that are run during the infra setup are pushed into the database operator. And so what that will do, the database operator and what the scripts are doing now is provision a database or attach to an existing database. And from that, generate a Kubernetes secret or whatever other credential location, vault, or whatever the case may be. It'll create this Kubernetes secret. That Kubernetes secret is referred to from your Kubernetes deployment. And so you can see how this is a very nice decoupling with Kubernetes, because your microservice can actually have its database changed underneath of it just by changing the secret that it references. And so you can plug the database in and out and things like that. So everything, again, everything's nice and decoupled. And so that's basically what's being said here. And then that Kubernetes deployment is bringing in the secret with your database connection information. And the deployment is feeding that into your microservice in one form or another. And that's how the microservice is creating it. And so the frameworks, in particular Helidon that I mentioned here, implicitly take things from the environment or whatever source and create a data source for you. So there's no code. This is all the code you need to get your data source and start doing work. So again, that database operator that comes out will make it even easier, and that will facilitate some of the observability stuff I'm going to go over in Lab 7 as well. And so with that, Richard, I'll hand it over to you to go over Lab 3.
Thank you, Paul. Hopefully folks have now got their setup completed. Just wanted to point out one additional step that was required to get the provisioning to complete. I did also post this in the chat as well, but you needed to run one additional command, which was to set state done K8s provisioning. If your setup is still running, if you could, and you followed the other workaround steps, then if you could run this additional step, then you'll find that your setup finishes in a few seconds. What I'm going to do now is work through the third lab in the and the fourth lab in the workshop and then I'll hand back to Paul, who's going to show you Lab 5. So what we've done so far is we've shown you the functionality of our microservice. What we want to show you now is what happens if you decide, oh, I'm not going to implement my inventory service using Java. I'll implement it with another language. And so what we're going to do is we're going to swap to a different implementation of the inventory service and show that the functionality is just the same. So the first thing we want to do is to undeploy the inventory microservice. But let me just run the setup first, so that we've got everything deployed like Paul had in Lab 2. So if you remember what Paul did, the first thing he did was to deploy all of the base microservices, and now we're going to undeploy the inventory Helidon microservice. So I will do this next. Okay, so I've deployed that. If I look at the pods that are running right now, we see we have the front end service, the order service, the supplier service, but we don't have the inventory service. So now you get to choose when you run this yourself. Believe it or not, we have, I think, how do we got to now? 7 different options here for different implementations of the inventory service. The source code for each of these is available in the GitHub repository, so you can compare and contrast each of these implementations. We have an implementation using PLSQL, which is running completely in the database. We also have a Python implementation that's running as a microservice in Kubernetes, Node.js, .NET, Go, Spring Boot instead of Helidon. And we also have the Java Helidon SE variant contrasted with the micro profile version. So you can compare and contrast those two. So I think I'm going to choose the Go implementation this time. I choosing at random, so I'm going to copy this here, and then I'm going to deploy the inventory microservice. And then if we look at the what's running right now, we see that it's just creating right now. And I'm also going to run the services command so I can get the front end running here as well. So let me just open that up in another tab. I enter my username and password as that I chose.
Okay, so the Polyglot workshop is really straightforward because you were just on the you're doing Lab 2, but you've undeployed the previous implementation in Helidon, and you're redeploying in one of these different languages. So again, you're just undeploying, deploy the language you're interested in. So we have a big variety of them now. And then you just verify the application functionality again. And so with that, and then, when you're done, you can go back to redeploying the original application using this command. So you just copy it and put it in the console. Okay. So it's no new functionality per se, just different languages and frameworks. And so with that, I'll go to the scaling lab. This is such a kind of can be done fairly quickly, but yet so powerful. You're basically scaling. We're doing this manually. Yeah, there's functionality to do this automatic, but we're doing it manually, so it's, you know, it can be a discrete presentation. And so the first thing you'll do is install a load balancing tool. We're using K6. In this case, you know, you can also use artillery. So basically, you're just creating an ingress. So for the stress test, we go through the order service. We don't go through the front end. We go directly to the order service. And so we're creating an ingress route to go directly to the order service. So you just verify that that's up, and then you'll go ahead and export that location, and then install the load tool. Like I say, it's we're using K6 here. It's pretty handy. And then go ahead and load, just CD to that directory and run tests. That's it. Then you'll be issuing a stress test against the order service. And then you can see the number of requests, etc., as the output when it's over. I think it's like 30 concurrent users, something like that by default. And you can tweak these scripts to, you know, to change these. And so then go ahead, and we're going to start by scaling the Kubernetes application tier. And so we're going to scale the order deployment to 2 replicas. We had 1 before. So then when you issue the pods, these are shortcut commands we have in the workshop. Then you'll see that there are 2 pods. And then so you go ahead and issue the command again, and you'll see performance is better. Now we'll go ahead and do that again, scale to 3 replicas, and execute it again. Okay, and eventually, you know, you're going to hit a wall, and see that it started to degrade. So now we'll take it to the database tier, right? We'll show the other side. So for task 3, we'll go into the console to look at the ATP instances that you created during the setup. And then you click on them, and there's simply a scale up down button. And so you'll hit that and increase those CPU count to 2. And then just wait for that scaling to complete. You'll see the lifecycle available. And then execute the load test again, and you'll see you know, increased throughput. And then task 4 is basically, you know, just your cleanup, scale it back down again to clean up. So that's, you know, pretty powerful, showing the scaling of both sides. You can, again, you know, the idea is you could take this, tweak the microservices, add your own use cases, performance test or stress test them, and performance test them, and things like that, you know, pretty simply with the workshop. So I'll now go into lab 5, which is observability. And so this is showing off that single pane aspect, multiple tiers, app and database tier, tracing, logging, and metrics in the same Grafana console. So the first thing we'll do is just go ahead and install all the software. So this one script will do all of this for you. It'll install Jaeger, Prometheus, Loki, Promtail, Grafana, and the SSL secured load balancer. So just go ahead, copy that command, and put it in your Cloud Shell. That doesn't take too long, to be honest. It's, you know, maybe 3 minutes, something like that, maybe even 2. The second command we'll do is conducts just what it says. It will create the Prometheus monitors, and the database and log exporters. And so the Prometheus monitors will scrape the microservices for metrics. And those metrics are what I discussed in lab 2 that are being advertised on the microservice endpoints. And then it will also scrape the PDB metrics via this metrics exporter. So the metrics exporter is its own devoted deployment. And I won't go into it too much, but just what you do is you provide SQL statements to it. It's very nice and dynamic. You provide SQL statements to it, and you'll see the example configuration. And it will go ahead into the database, get those metrics, and populate them so that Grafana can display them, so that Prometheus can scrape them and Grafana can display them. And so we have the same thing for logs. We have a log exporter. You mention what logs and or queries that you want. So your alert log, your trace log, whatever you want. And it will grab it from the database and log it in Kubernetes so that it can be received by Promtail and sent to Loki. And then Loki is the data source for logs in the Grafana. And I'll show that, visually in a minute. So it will do this with all the defaults, create the config maps, deployments, all that for you just by running this. And then if you want to add your own, later on, add your own metrics and things like that, all you have to do is go in and, add some queries to the config file and then run this and populate it. So again, hopefully, you can do development off this if you want. The next thing we will do is configure Grafana. So you'll get issue services command to find the Grafana load balancing IP that was provisioned in step 1 here. And that'll take a few minutes, maybe no more than 5, generally like 3 minutes, something like that. It depends. And so you'll find out the IP for that. It'll be pending until the IP is ready. And then go ahead and just hit that IP in your browser. You'll have to do the same, accept the self-signed certificate that you did for the front-end microservice, and then issue the admin with the password prom operator. And then what we're going to do is go ahead and just add the data sources. Grafana works off of data sources. And so we're going to add the data source for Prometheus metrics, add the data source for Loki logs, and add the data source for Jaeger open tracing. And so the first thing we'll do is just verify that Prometheus was set up during the install, actually. So for Prometheus, we're just verifying that. So you'll be in Grafana, you select data source, select the one that exists there already, and then go in and just go ahead and click save and test, and you'll see that it should be working. That's all for Prometheus, it's all set. Jaeger is not much more. You'll go into the data source tab again, click add data source. There are a list of data sources. It's usually short enough where Jaeger's on there, but if you have to search on it, just search on Jaeger, hit select. Go into the settings and enter this URL for this URL. And then just as before, hit save and test. And now you have a Jaeger data source. So it's just wired up, super easy. For Loki, it's the same idea. We do a little bit more. For Loki, go in, data sources, add data source. Find Loki and hit select, just like the others. Hit enter this URL for Loki. And then the one additional thing we do for Loki is enable the logs to trace functionality. And the way that works is you're basically providing a mapping, which is called a derived field. And you're saying to Grafana, giving it a name, giving it the regular expression that you see in the logs, and then what it should do with that. So show it in the actual screen. Here's the information you need right here that you're going to be entering. Just copy and paste it in. You're doing 2. You're doing 1 for the logs that are coming from the Kubernetes microservices, which is this, and 1 that is coming from the database logs, which is this. And again, we don't have so much time now, but we have just these great projects existing and future as far as all these observability technologies with the database. And so there's a concept of an ECID, which has been around for decades in Oracle, where you can trace through the database. And so when you have a mapping of the open tracing ID in Jaeger to this ECID, which is what we're creating here, you can trace all the way through all your different microservices all across Kubernetes and into the database, and then correlate the logs and tracing with it and metrics. So, I mean, it's really an awesome top to bottom, left to right solution. So that's what we're doing here. We're just mapping. And so you'll do it once for that, the Kubernetes logs, once for the database logs, and then you can put in a sample log just to test it before you then go ahead and say save and test, and that'll verify that. Next and finally, we're going to go ahead and put in a dashboard that I wrote for GrabDish. Pretty basic dashboard, but it shows all of these, these three different areas across app and database tiers. So in order to do that, you'll go ahead and hit the plus sign on the left of Grafana there. You'll hit create and import. And then you'll go ahead and get the copy the JSON from here. So when you click on here, it gives you this raw output. Go ahead and select this. This is the dashboard definition, and drop it in this import panel and load it. Okay, and then just go ahead and hit import, and now you have the dashboard. And we'll move on to task 3 to view it. So you'll go ahead and select dashboards. In dashboard, you'll see GrabDish dash that was just imported. And you can go ahead and see the whole dashboard for this whole workshop. So that's all it took. And what you'll see is it's basically in 4 sections here, and it's divided by microservice. So it's divided by bounded context, but across multiple types of observability and across multiple tiers. So basically, so it's the front end microservice, the order microservice, and the inventory microservice. And so I'll zoom in a little bit here. Okay, that didn't help too much, but hopefully you can kind of understand. For each microservice, it basically has its own tab, but 4 areas. And so the one area is the Kubernetes microservice services kind of runtime information. And so that's your CPU, thread count, things like that. And then the other section is statistics from the Kubernetes microservice specific to that, that are advertised specific to that microservice. So for the order service, we have like a place order statistic that you're showing, okay? So on the left is your Kubernetes runtime and app specific. On your right is your database runtime and app specific. So your runtime is like your sessions, the number of messages in your queue, and then your app specific is like the number of orders by their status, pending, failed because inventory didn't exist, or success, okay? And so you can see all this in your metrics. This next section, just kind of step forward just really quickly, is showing how you can just modify the panels a bit. So you could have, for the status, you may have 1 instead of up. And this is just showing you that if you wanted to map them, you could put 1 here and say that 1 should be up. Okay, there's endless numbers of customizations in Grafana, different panels and stuff like that out there. But so I'm just showing you a super basic way to customize. So now the next thing you want to do is either issue another app request, or if you just finished the scaling test, you probably have app request, but just something to make it show up in the console, okay? So if you just go through and place an order, you'll get a little blip like you see here, just to get some activity on here. And then from this metrics screen, in the next task, we're now going to drill down into logs and tracing. So on this screen, whatever you see on the screen, when you click down the drop-down menu in one of the statistics and hit explore, that's the time frame you're going to see in this explore window. So we have this request that we're seeing here. We hit explore and we're going to see the time frame that includes that request when we go to the explore window. So it just brings you to another window called explore, and brings you to the metrics there. Now you can go ahead and hit split, and it will bring up 2 screens. So you can have up to 2 data sources that you're looking at in this explore, okay? So on the left, and so we have Prometheus on the left, and then with this drop down, you can select Loki, which again is our logs on the right. Sorry, this picture is a little small, but you're splitting the screen and then selecting Loki for this drop down box, okay? Then if you select the chain here, What that will do is keep these two in sync as far as time. So as you're moving your cursor on things on the left and on the right, it's completely in sync between the two. So you're looking at the same thing, the same time for your metrics and your logs in this initial case we're showing, okay? So now let's take a look closer at the logs. If you click down on Log Browser, there are a bunch of labels that you can search on. And one of them that we're going to use here is the app, okay? And so we select app, and then you'll see the different values for the different labels for the app. And we're going to select two of those labels. We're going to select order, which is the order Kubernetes service. And we're going to select DB log exporter for the order DB. And so what we will then see when we show the logs is the logs both from the mid-tier and the database tier, collated, or however you want to call it, below. So that's nice. You can correlate the two tiers, right? Then we're going, and you have different ways of sorting this. I'm not going to go too much into it here. Different ways of sorting it by, info, error, whatever the case may be. So if you find, go ahead and click on one of these messages, particularly in info one, you will see, and like I say, you can do this for either the Oracle or the order app tier microservice log or the database alert log that we're bringing in. Either of them, you're going to see the correlation that we made earlier, the derived fields, and a button to do the logs to trace functionality. So then you click on that Jaeger button, and that will take you to the corresponding trace for that log. And so you can go back and forth. Super powerful, right? Then you can see, okay, something went wrong in the log, whatever the case may be, a number of different things we're doing here. Then it goes into the trace, and then you can see the information in the trace, where it came from, things like that. So very powerful observability. And that's basically what we're showing in that lab. It sets it up fairly quickly. Let's move on to lab 6. So we have 25 minutes to go through the last two labs. That should be just enough.
So I'm back, Paul, if you'd like
okay.
to do lab 6. I apologize to everybody. I'm not having much luck today. My laptop exploded. The wheels came off at least. So do you want me to jump in, Paul?
Yeah, sure. Thanks.
Okay, thanks. Okay, so what we're doing in lab 6 is to show how quickly and easily you can create an application express Apex application on top of everything else that we've been doing. The nice thing about the OCI console and the autonomous database is that all the application express functionality is integrated right from the beginning. So there's no additional setup to do. So what I'm going to do here is show you how we can take, I navigated to the transaction processing databases, the autonomous transaction processing databases that we created in the dev compartment that I showed you earlier. And you can see that it created two, the inventory database and the order database. If I select the inventory database, I'm going to create an application on top of here. The first thing we do is select tools, and we say open Apex. As you can see, all of this is integrated in, and it's very simple to do. It's going to pull up a screen where I'm now going to basically, first of all, I'm going to log in first, and this is the password that you set right at the beginning when we were doing the setup, and that allows you to log in to the administration services, and then we click the button to create a workspace. We select the database user, in this case inventory user. This is the user in the database where all the inventory data is, and we create a workspace. We then select this link here, and it it logs us into this workspace, and then we type in that password again. And then we set the Application Express password for the specific account that we want to use for logging in. So to do this, we need to set an email address. And we also need to set a new password here that we're going to use for, this is now it's not our database login, this is now going to be our application login. Okay, so I've got a password set here. And now what I'm going to do is to click the app builder icon, which creates an application. And then I'm going to click on the create icon to create and I'm going to create a new application. Lots of other functionality here. I'm giving you a very brief overview. And now what we're going to do is we're basically going to start painting screens inside here. So I'm going to create an application, give it a name, and then I'm going to create an interactive grid page, which is going to look at the inventory. Actually look at the inventory table. So if we go here, we select that. We now add this page to the application. And believe it or not, we're already at the point where we can create the application and log in. So when they say low code, it's actually in this case 0 code. The application is created, and then we can run the application, and we can log in with the login that we created earlier. This is just a very simple example of what can be done with Apex. But this is now a view into the inventory table, and you can even go in here and you can edit data in the inventory table. Like I can add an inventory item in here and save that, and it's updating the table directly. So a very quick example of how you can create an application on top of your tables, on top of your other data in the database, and get started really quickly in prototyping, in providing, useful application interfaces for different users that may be interacting with your microservices in the database. Okay, so Paul, over to you to talk about transactionality.
All right, thanks so much. Someone asked a great question for the lead into this lab about, let's see, with JMS-based eventing for AQ, will it be scalable? Will it give guarantees like Kafka at least once in ordering? And the answer to that is definitely yes, and actually provides more. So I talked about this a bit in the presentation, about the fact that Kafka doesn't have this ability to do transactional access as far as guaranteed once delivery, like the implicit idempotent consumer. In other words, the application does not need to keep track of IDs or anything like that to ensure that if it gets duplicate requests, it's not inserting something twice into the database and stuff like that. And that's the application does not need to handle that whatsoever with AQ. Guaranteed order, guaranteed at least once delivery, as I just mentioned. And so this is actually a blog that I wrote that pretty much corresponds to this last workshop that I'm going to describe. So I'll put that in the chat too, actually. Okay, so I'll plug my blog while I'm here. Okay, and so that goes into some details, and as always, please contact us, for any other details. But this goes into some of the questions you just asked, and then this lab demonstrates them. So what we do here is set up the application, the exact same application we've been using, order inventory. And we do it with the version that we have with Oracle Database and AQ, TQ, and with a version that's running Kafka with MongoDB and Postgres, okay? And so this is the matrix of the tests we will do comparing the two. And so these are the different service types that I just mentioned, whether it's Mongo, Kafka, Postgres, or Oracle. And then these are 3 scenarios where we crash the microservices at different points. And so the first, I'll go through this and then describe the behavior as we walk through. The first is if we were to zoom in on this. Okay. Crash the order service after the order has been inserted, but before the message has been sent to asking, the message being sent to the inventory service to see if the inventory exists. And then the second scenario is where the inventory service is crashed after it received the message, but before it checked and modified the inventory. And then the third scenario is when the inventory service crashed after it got the message for the order and it modified the inventory, but before it sent the message back to the order service conveying that. So I will come back to this table. This table is really the important part, showing the aspects like that. But I'll come back to it after I just kind of mention the setup. So the first thing you'll do is go ahead and install Mongo, Postgres, and Kafka. And again, that's just this one script. We'll do all that. So copy and paste that in your Cloud Shell. And then undeploy the existing, excuse me, order inventory service that's backed by Oracle. And you can do that with this command. And then go ahead and deploy. This is all one command to undeploy the old and deploy the Mongo Kafka Postgres version. Then go ahead and check the pods, just make sure they're all running. And then we'll run those scenarios against Mongo, this combination, and then we'll undeploy it and we'll run the same scenarios against Oracle DB. So we'll do this by using these menu options that are on that main order page. And so the first thing you want to do is just to make it easier, go ahead and crank up the inventory, add inventory, and get until you get 10. And so we don't have to bother with it in the future. So just add a lot of inventory and then hit the crash order service after the order is inserted. Okay, that's the first scenario I mentioned up top. And what this says is it sets that in the microservice, and it says, the next time you get a request, on the next request, do this crash behavior. It'll crash itself intentionally. So we can test this. So then go ahead and place an order, and it will come in, and as I say, it will crash before the order message is sent. So the order is inserted. So the first thing that'll happen is you'll have a hang because the order service crashes before you can get the response back. Of course, that makes sense. But then when you hit show order, you'll see the request is in pending state. So there was an order placed, but it's in pending state. And that the inventory is not adjusted as you might expect, okay? And so the problem here is that this order is in pending state and you've not been able to send the message to the inventory. So this is left in a pending state and something has to clean it up. A code or admin, whatever the case may be. So that's not good. So now let's try the second scenario where we're going to crash the inventory service after the order service is received, but before the inventory for the order is checked, okay? And so here, we'll place the order again, and we'll notice that again, the order status is in pending state. And we go and click the show order button. And we see that the order was successful, but the reason it was successful is because there was a duplicate message delivery. And so in this case, we're showing, something went wrong, but maybe in this case, the order will go through. But in this case, you will see that there are duplicate log entries. So, it may just be that case, and your app was written in such a way, whatever the case may be, but you're getting a duplicate delivery, whatever the case may be. The next scenario is a duplicate delivery where we see that it's not a safe case. And that's if you actually adjusted the inventory already before the crash happened. And so when this happens, you place the order, the order is in pending state. But when you go to get the inventory has actually been reduced. Okay, so you got this duplicate message delivery, and therefore you reduced the inventory to lower than it should be. You certainly can't have this. And so for the sake of time, I'll just go back to the chart here, and you'll see in these cases, when you're using Oracle AQ, because you have that transactionality between the message and the work you're doing, this order will, in the first case, if the order crashed, it will be automatically rolled back. You won't have a pending order to clean up. In this case where you get duplicate message delivery, you won't have duplicate messages in the logs, because it'll only be if it crashed, the message is rolled back and put back on the queue. It's not re-delivered a second time. And this disastrous outcome here, it will be the same thing. It will be automatically rolled back. You won't have a duplicate reduction of the inventory, which, and then your inventory numbers are off. So, you can write code, and in even some cases, you can't even write code to handle this, but you can write code and it's going to take explicit error handling. Okay. And so especially when you're starting to, for one, the convenience to your developer as far as needing to write this code. And again, you shouldn't be writing things like this. Like I said, with service mesh and event mesh, you should be moving these cross-cutting concerns out of the microservice. It should be domain experts that are writing your microservice, people that know about that business logic. They shouldn't need to know, about handling duplicate messages and things like that. And then it becomes even more critical. You're talking about inventory and banks and things like that. You want these transactional guarantees. And so, that, and then imagine the case where you're migrating from an old system. The old systems were not written to be idempotent because it was all in one process. They didn't need to handle multiple message delivery. And the old systems were used to this data integrity from locking protocols. And so, it's just a much safer, much simpler, more robust solution to use this Oracle AQ combination, the Converged database. And so with that, I'll hand it back to you, Richard, to do the teardown.
Okay, thank you, Paul. The last thing I wanted to do is work through the teardown process, which is very simple. Because some of you may have had to work around that issue with Terraform, I just wanted to add a couple of things in here. I'm noticing, you can see in the bottom of my screen here, that some of the Terraform scripts are still running in here. So the first thing I want to do is kill all those to make sure that they're all gone. So I'm doing a ps-ef, and then I'm going to start by trying to kill the Terraform apply script here, and I'm hoping that kills everything else, but let's see what happens. It's still hanging on here, so difficult to kill everything here. So let me see. Did I get still one more? So I'm going to kill that last one as well. This is so that we're going to use Terraform also to destroy everything, and so we want to make sure that okay, so everything's gone now, and so once you've done that, then you want to be in the grab-dish folder, and you just type source destroy. And what this does is it goes through and it cleans out the repository entries. It clears out the Kubernetes cluster, the databases, anything in the object store. And the reason why it's important to do this is that you probably want to run other workshops inside your tenancy. And so this is a very convenient way of flushing everything out of your tenancy, so you can jump into other workshops knowing that everything's been cleaned up. This will take typically about 10 minutes to destroy everything, but you can go off and let this go off and do other things and let this run while you're doing other things. And that's the last step in the workshop steps. I don't know, Paul, if you had anything else to say before we sign off.
Yep. Yeah, I'll close it out with the slides and give it to Tara as well.
Okay, so let me stop sharing here.
Okay, so these are additional resources. Tara,
Yes, thank you both for the great presentation. So these are just some additional resources. If you enjoyed today's session, we'd like to also invite you to our next one, which will take place on October 6th. And this one, you'll learn how to build and tune your machine learning model using race data from Red Bull Racing Honda. So I can drop all of these links in a second. We have our lab guide again, and then this is an email that you can reach us at if there are any questions that do come up about the lab or any other live labs that we have. Here is a blog as well that might be useful. And then we also encourage you to share with us any feedback you have on today's session or what you'd like to see from us going forward. So I will drop those links. And then we also have one last slide. So as I mentioned earlier, we do have a quiz. We'd like to test your knowledge on what you learned today. So by completing several questions of the quiz correctly, you'll achieve a social badge and you can share that on your social media. Thank you everyone for spending your time with us here today. Thank you, Paul and Richard, for the great presentation and everyone for their help. I will go ahead and end the recording.